So the reason I'm recording number 2 from the practice exam is because it was significantly different from number 2 on the spring 13 exam, which is the whole other series of videos from spring 13. So my students wanted to see this. So the trick with this question is that this mess right here, it doesn't actually matter because I never ask you to do anything with that function. So pretend like that's not there. In 1774, so if this is time, this ends up being time, this 0 is 1774. The rabbit population is approximated by some function, which is measured in years, and the graph is given below. Estimate when the rabbit population grew most rapidly. So what it means is we're looking for a point of inflection. You see everything from down here is going to hold water and everything up here is going to spill water. So that's a point of inflection. And so how large was the population at that time? 1,000. Well, estimate when this is occurring. So I'm going to drop a line down so I can estimate. So this is, I'm going to guess about 1/3 of the way over, but if you said 1/4 of the way over, that would be fine too. So it's somewhere between 12 and 16 years. So what's up? 50 over 3 is approximately 50 divided by 3 is, it's about 17, 16, whatever, because we can round down because it's not quite 1/3. And then 1774 plus 16 is going to be 1790. Okay. Find the inflection point on the graph and explain the significance. Okay, so it's 1790, 1000, or if you want to label it as, 16, 1000. Those are both valid. Okay, so what's the significance? This is exactly what we said before. Fastest rate of growth for the rabbits. It's not when they reached their max, but it's when they were growing the fastest. What natural causes could lead to this shape? But when you ask that kind of question in a math course, what we're asking is, why does this asymptote occur? That's really the question we're asking. And the standard answer is predators running out of food or space, because they're on an island. So running out of space is kind of like running out of food, but there's, depending on what it is that they do and how territorial they are, they may just, reproduce less if there's less space. Okay, so any of those answers are fine. But you see we had no business worrying about this function. If you wanted to worry about this function, let's say you got distracted. The derivative is, okay, the bottom has to be squared. Square this guy. Bottom times the derivative of the top. Derivative of top is 0. Minus top times the derivative of the bottom, so it's going to be, nope, I'm falling into the trap. Oh no, save me. It's this whole exponent, come on in, just a second, times negative 0.4. Anyway, it's nasty, don't do it.